So this week we're going to be talking about 1 and 2-step equations and how to solve those. Anytime we are solving an equation, really we're just kind of undoing what is being done. The whole idea is to get a variable by itself. So you hear all the time about solving for x. The idea in solving for x is to get that x all by itself. So let's put up here the main idea behind solving equations is to get the variable by itself. What does that mean? It means that we are going to take an equation. So if I have an equation like m plus 12 equals 10, I have to look at whatever's being done to that variable. Now, if you remember, the variable is the letter, means it could be anything. It varies what it could be. In the terms of an equation, though, it can usually only be one, maybe two things, depending. And the way that we get it by itself is we undo whatever is being done to it. So in this case, you can see that we are adding 12 to it, right? What is being done to the m is that 12 is being added to it. And so we need to undo that. And the way that we undo something being done to it is we do the opposite. So here, if I am adding 12, to undo it, I would subtract 12. The thing about an equation, though, is because we have that equal sign, if we do it to one side and we don't do it to the other side, we're messing with the equality. And so to keep it equal, I can do anything I want to this side of the equal sign as long as I also do it to this side of the equal sign. So to get the 12 off of this m, I have to subtract 12, but I also have to subtract it from the other side. And here, 12 minus 12 is 0, so I'm just left with m on this side. And here, 10 minus 12 is negative 2. And that's really the only thing that we are talking about when we discuss solving equations. Really, we're just saying get the variable by itself so we know what it's equal to. And the way we do that is we undo everything that's being done to it. If you have a variable on more than one side of the equal sign, get all of them on the same side and then undo it. So if I have, for example, negative 7y equals negative 91, I can look at that and I can go, well, there's only one thing happening to this y, and it is being multiplied by negative 7, right? So for me to solve that, all I have to do is the opposite of multiplication, which for us would be division, right? And so I would divide this by negative 7, but I would also have to divide this by negative 7. Negative 7 divided by negative 7 is 1, so all we are left with is y, which is what we want. Negative 91 divided by negative 7 is going to be a positive number. In this case, it would be 13. If you don't know that, though, use a calculator. You don't have to know it right off the top of your head. Right? There's no shame in the calculator game. Don't worry about this. I'm going to erase all of this, but I thought I was using a clean whiteboard and I wasn't. we still have plenty of room. Now, what we're doing here are what we call one-step equations. And what makes them a one-step equation is that we are only having to do one step to find the solution. So in this one, our one step was we had to subtract 12 from both sides. And this step, we had to divide by -7. If I have, clicked on the wrong dang thing. If I have, say, G minus 9, G and 9 look a lot alike there, equals -2. Here, all I'd have to do is add 9 to both sides, and I would wind up with G equals 7, right? So nothing too difficult going on there, but sometimes you might find a little bit more complex problems where you have to work a little harder at it. Say if I had x over 9 equals -4, right? If I'm dividing by something, all I have to do to get rid of that division is multiply by the denominator, right? In the same respect that up here, when we were multiplying by -7, we divided by -7. Here, we're dividing by 9, so we're just going to multiply both sides by 9. And we will wind up with x equals -4 times 9, which is -36. Occasionally, we're going to have to deal with fractions because fractions are a legitimate thing, right? Parts of a whole, and we have to deal with them all the time. But they're really just division problems. Anytime you have a fraction, so say I have 2/3 x equals 10, and I want to figure out how to get rid of that or how to solve that. If I have this 2/3 times x, anytime I'm multiplying something by a fraction, if I want to get rid of that fraction, all we have to do is what is called multiplying by the reciprocal, which means that I am just going to flip this fraction upside down and multiply by that. I have to do it on both sides, right? What happens when I multiply a fraction times a fraction is they multiply across. So that would be 3 times 2, which is 6, over 2 times 3, which is also 6, equals, what's that, 10 times 3 is 30, over 2. Here, this just becomes 1. Any number over itself is just 1. So we wind up with just x equals 30 divided by 2, which is 15. We call it multiplying by the reciprocal. The reciprocal just means you flip the fraction upside down. That's all a reciprocal is. And you can get rid of most of your fractions by doing that. If I had, say, 4/9 m equals -8, I would just multiply this by 9/4, right? And again, we can't just do one side of the equation. If I'm doing it on this side of the equal sign, I also have to do it on this side of the equal sign. And here I would get 9 times 4 is 36 over 4 times 9, that is 36. Do I have to do this all the time? No, right? I just know that if I multiply something by its reciprocal, I'm going to get 1. -8 times 9, well, that's going to be -72 divided by 4. And here we would wind up with m equals -18. So this is what we're talking about when we're talking about one-step equations. Two-step equations Just means that we're doing more than one step to get there, right? There really isn't much of a difference. So if I have, I want to erase those boxes there. That's all right. I won't do too many two-step equation examples then. Say I have, for example, 6x plus 8 equals 50. Notice that we have more than one thing being done to this x. Our x has this 6 that's being multiplied to it, and it has this 8 that's being added to it. We are always going to deal with the addition and subtraction first when we're dealing with more than one step. You want to do backwards PEMDAS. We've been taught that PEMDAS is parentheses exponents, multiplication and division, whichever comes first, and then addition and subtraction, whichever comes first. But because we're undoing it, we want to do it in backwards order. So what I'm going to do is I'm going to start by getting rid of what is being added to it, which is this plus 8. So I'm going to subtract 8 from both sides, and I will get 6x equals 42. Now I can deal with what is being multiplied to it. It is being multiplied by 6, so I'm just going to go ahead and divide each side by 6. Here I will be left with x. 42 divided by 6 is 7. That's all we got going on there. Let's look at one more. I'm not seeing anything any more difficult, but let's look at 13 equals negative 4k plus 9. Same respect, right? We're going to do the opposite first. Just because it's on the other side doesn't mean we can't work the same way. So I'm going to start by subtracting 9 from both sides. 13 minus 9 is 4 equals negative 4k. And now all we have to do is deal with that negative 4 that's being multiplied to the k. And so we are just going to divide by negative 4 because that is the opposite of multiplication. And I'm going to have, here I'll wind up with 4 divided by negative 4, which is negative 1. And that is just going to leave me with k, and we'll be left with k equals negative 1. So that's really all there is to 1 and 2 step equations. I am not going to take it further than that for you guys. There will be an assignment for you on Delta Math, but because we have next week off, I don't want to overload you with work. So if you have any questions, feel free to ask, and I hope you enjoy your week off.